My name is Chloe Avery. I am a mathematician, actually. I work for Orchid. If you're familiar with Orchid, we have a VPN marketplace, but we're actually launching a new project. We're building a decentralized data storage system. We're calling it Storchid, Storage, Orchid, Storchid. There we go. So one question that you might ask is, why decentralized data storage? I mean, in this space, we kind of love to throw the word decentralized in front of things, but why storage specifically? So one of the things that can happen is when you're storing your data with, a single company, that company can go, products can go defunct, that company can no longer exist, or they can start making you pay higher and higher fees. They can hold your data hostage. So we love decentralized data storage. The idea is that you're going to store your data with lots of different providers. So our goal is to design a system which is trustless, incentive-aligned, configurable, and decentralized. So there are sort of three main parts of our design that I'm going to talk about. The first one is provider selection and payment handling. We'll talk about audits, and then we'll talk about file upload, download, and maintenance. So one of the things that we use is stake-weighted random selection. So if you've seen our VPN project, you might know that we have a directory where providers can, and this is going to be the same for the storage project, we have a directory where providers can stake some amount of tokens, and then they will receive a proportionate amount of service. And then the other thing that we have is nanopayments. So the idea behind nanopayments is to be able to send tiny, tiny amounts of money. And I'm such a nerd. I'm a mathematician, so this is really cool to me. The idea behind this is, say I wanted to send you a penny. A lot of times you can't do this actually because, or maybe fractions of a penny. You can't do this because there's going to be fees. You might not have to send some minimum amount. So instead of sending you a penny, what I'd do is I would send you a 1 in 100 chance of getting $1. And if you do this enough times, law of large numbers and all, you'd actually end up receiving kind of the same amount of money. So that's what nanopayments are. We're going to use those to pay for storage. So if you're storing data and you store it in just one location, that can be incredibly dangerous, right? Something could happen, locally. So instead, the idea is that we're going to break up our file into a bunch of pieces. And we're going to do this by using something called erasure coding. It's this really cool math stuff. So what the idea is that we're going to break our file into, say, n pieces. And you do this in this particular way such that any k can be used to reconstruct the file. So maybe an example here is, say I broke my file into 40 pieces. Any 20 of them could be used to reconstruct the file. This is really nice because if some of those storage providers go offline, you're still going to be able to have your file. So this is super robust. And actually, we go a step further. We use something called twin coding. And the reason that we do this is because it actually turns out that it costs a lot when you're doing repairs. You have to pay for bandwidth. And so we use twin coding in particular to mitigate bandwidth costs. And then a lot of other decentralized data storage projects add another actor called an auditor. So if you're having a bunch of people store your data, you're going to need to make sure that they are actually storing your data, right? But the problem is that adding an auditor is just another person that you have to worry about trusting. So what we do is we do not add an auditor at all. We have two types of audits, interactive and non-interactive. Interactive audits happen when the client is online, and that's just direct communication between the client and the provider. The provider is able to provide proof that they are actually storing your data. And then when the client is offline, this is where it gets a little tricky. When the client is offline, the auditor or the providers will actually self-audit. They will provide proofs that they are actually storing the data. They check each other, the providers check each other to make sure that the other providers are actually storing data. And they're incentivized to do so because if they find out that another provider is not storing their data, then they will get some fee. And the other thing is, sorry, I'm forgetting what I was saying. So storage providers will audit each other. Oh, and then storage providers post their proofs on chain, which I know what you might be thinking. That sounds like that's probably going to be incredibly expensive. But we actually mitigate this cost by using something really cool called proto-danksharding. Maybe you've heard of this. It's very neat. Yeah, so if you want to know more about our storage project, come talk to me, come talk to the other Orchid folks, scan this QR code, read our light paper. Yeah, we'd be happy to talk to all of you. Thank you.
Great, thanks very much.